All right, so today we're going to be starting our new unit on acids and bases. Before we get into the notes, I just wanted to take a few minutes for everyone to think about what we already know when we hear the words acids and bases. And then what we're going to do is we're going to add to that information. All right, so take a few minutes, do a brain dump. So think about acids, think about bases. What do you know about them? Where have you heard them before? What are some examples that you know of, oh, I think this might be an acid, or I've heard about this being a base before. Okay, so take a few minutes and do that. I just want you to pause the video while we're doing that, and we'll go from there. All right, great. Okay, so now we have a starting point that we can work from. We know this is the information that we already know about acids and bases. What can we add to it? So I want you to look through your list and I want you to see if you can find any common threads. What are some things that are happening with a lot of the acids, or some of the things that are similar about the bases? Okay, make a little note underneath your acid column or your base column about some things that you notice. We're going to use this starting point to decide how did chemists and how did scientists originally define acids and bases. What they did is exactly what you guys just did. They said, all these things are kind of similar. What's going on with them? I'm going to categorize them. I'm going to put them all in together. So what they noticed was that acid was something like vinegar. And some things that were similar to vinegar and had similar properties, okay, they also kind of had this bitter taste. Okay, they were bitter taste. You should never taste chemicals, right? And they also had a bitter smell to them. So that's what they called an acid, something that was bitter, all right? A base, on the other hand, that was something more like the ash in a fire, like in a campfire, or just the ashes, you know, if you light a fire, there's ash, okay? That ash is a base, okay? And something that they found common about a lot of base is that they're slippery. They're slippery to touch. So bases were things that were slippery, and acids were things that were bitter and sour. Okay, so I want to make sure, I hope you guys were copying this T-chart down and making some observations about what were acids and what were bases. That's going to be really important for your notes. Before we get into our first scientist definition of an acid and a base and what their theory is, what we're going to do is we're going to talk a little bit more about solutions, okay? Because every acid and every base that we're talking with and we're working with and talking about is going to be in a solution, okay? So what we need to know about solutions is that when something's in a solution, it goes into its ions, okay? So NaCl isn't a chunk of NaCl, okay? What NaCl is, if you look, it's Na plus, okay, and it's Cl minus, okay? So it's called dissociation, okay, of these ions. And if you look up, you remember Na is group 1, so it'll form a 1 plus, and Cl is group 7, so it'll become a 1 minus. Okay, so in a solution, NaCl isn't one thing chunked up together. It's two separate ions that move independently of each other. Okay, and this is actually what the first chemist was studying when he started looking and making some observations. And what he was looking at was HCl. Okay, he was using this and some other similar compounds. And HCl forms what? What would my two ions be? I'll give you a minute to write it down. All right, it's going to split apart into your hydrogen ion, your H plus, and it's going to split apart into your Cl minus. Okay, so this is actually a very important one for us to look at because HCl is a strong acid. Okay, so let's see what our man Arrhenius was talking about. Okay, so he was trying to prove that there were ions in solutions. And when he was doing this, he started making some observations. Okay, all of those things that were bitter and that we had termed acids, they also formed H plus in a solution. So they formed that H plus in a solution. So we said maybe an acid isn't something that tastes bitter or smells bitter. There's chemistry behind that. There's more information. Let's narrow that down a little bit. So he said, I think it's all about the protons. Okay, I think there's protons. And then what about those bases? What's going on with them? Well, he's looking at aqueous solutions, and what he found was the common thread of OH minus. Okay, so that was going to be for your bases. Okay, so this is acids over here with your H plus and your bases. They all produced OH minus in their solution. Okay, so Arrhenius' theory. He said acids produce those hydrogen ions in your solution. Okay, HCl becomes H plus, right? HCl becomes H plus and Cl minus. I apologize for my sketchy handwriting. Okay, and then the bases, they always form OH minus. And remember, that's a polyatomic ion. Okay, OH minus is a polyatomic ion, so it kind of hangs out like a gang. All right, it's also called hydroxide, which hopefully we remember. All right, let me get that minus in there. Perfect. Okay, so NaOH forms OH plus, NaOH forms Na plus and OH minus. Okay, so something I want you guys to think about is, what about water then? Because water is H2O. So remember, sometimes we write it HOH, okay? And if we write it HOH, we know that we ionize into H plus and OH minus. So I want you to think about what you think water is in Arrhenius' definition, okay? What would water be? A second one that I really want you to think about is, what about baking soda? Okay, baking soda is NaHCO3, okay? That's sodium bicarbonate. And what we can see is, can we pull off an H plus easily? No. Okay, actually this H right here is part of a polyatomic ion that actually has a negative charge. So if you separate this into ions, it's actually going to be Na plus, and then it's going to be H C, oh, that's a little sketchy, sorry guys, CO3, 1 minus. Okay, so based on this, baking soda is not an acid and it's not a base. If any of you guys have ever been working in the kitchen and spilled some baking soda on your hand though, you'll notice it is a little slippery. It's actually a base. It's a weak base, but it is a base. Okay, so what we see is the limiting factor in Arrhenius' model is that not all bases are going to be OH minus. Okay, there are bases that are not OH minus. So I'm going to write that in for you guys. I want you to follow along, make sure you're writing with me. Not all bases. Hopefully your handwriting's a little bit better than this and is in a straight line. So not all bases have OH minus, and that's a huge limit in Arrhenius' model. And so what we see is that we're going to learn another model of someone else that redefines what an acid is and what a base is. Okay, the first guy who comes up with an idea, it's not going to stay, right? We're always learning more, and that's what we learned here is that, you know, there's our categories aren't the best we can make them. So we're going to learn our next guy tomorrow, and that's going to be Bronsted at Lowry. Okay, so Bronsted and Lowry are going to take their next stab at redefining what an acid is and what a base is. So I just want to give you guys a reminder. Please, please, please make sure you are writing down all of your notes, all the new information. Make sure you have your examples in there, and then make sure you have 1 or 2 minimum questions that we can talk about tomorrow at the beginning of class. So it's your job to come prepared with 1 or 2 questions that you have about this lecture. So just make a little star and write them in there, or you can write them right next to your notes, okay? Either at the end of your notes or in the margins. I'm going to be looking for it tomorrow. All right. See you then.